Alright, y'all. So we have a sliding window problem where we're trying to find the max sum for a given window. So this test case, the sample test case, pass in an array, the size, and the size of the window, and the output array. So in this, our max sum is going to be 367. So it's going to be this end. So let's make a new function. Sliding window max. Okay. It'll return the size of the window. It's just called sliding window max. Okay. We pass in an int original array, int orange size, int out size, and then int output array. Okay. First things first is we're gonna return the out size. Okay, so for sliding window, we need to let's pull out paint. We need to have, where are we? We need to have one pointer, pointer or index here, and then one n plus I away, where I is our output size, or window size. Window size is better, but okay. Alright, with this in mind, we will start with an I equals 0, int j equals, you know what, better names, left, right, equals left plus outside, or window size minus 1. Right? Because to start is 2 given 3. Yep, makes sense. That was weird. Okay. We also want to keep a sum. And do we calculate sum right away? Let me think about this. We want a sum and a temporary. And sum equals 0 to start. We'll start there. For int I equals left, I less than right, I plus plus, and we will just sum plus equals original of left. Actually, yeah, no, we need to do this. Okay. So we have our initial sum of window, and then when we increment, we just need to see if, okay, let's say we slide our window. We have a fixed size, so essentially this one's going to move to here, this one's going to move to here. So we will essentially remove this value and add this value. So the basic flow as we increment through this, we want we'll make copies. So, and then we'll update left and right after. So we'll have ni equals let me think about this. I'm thinking we only need to increment the outside, or right. So I equals right. So I will start at 2. Yep. I less than original size. And for sanity, we can print f init size. And this will be sum. Okay. Let's include our standard IO. Okay. Now we have less than original size. I think we want less than window size. We'll see though. If we're over and that's sum, then because what should it be? 1, 3, -1, so it'll be 3. Okay. Alright. Here we'll start with right plus 1. If let's make a sum copy as well. Int sum copy equals sum. Okay. If how is this gonna work? Actually, we might not need a sum copy, but if sum minus original of left plus original of I is greater than sum, then sum, then we update. Update all values. Found new max. Okay. So we do sum equals sum minus equals original of left, and then sum plus equals, we will also increment the left because we have a fixed size window, and then ooh, I see a bug here. Let's think it through in a second. We know this logic is at least somewhere right. Okay, So my thinking here is if we're incrementing like this, we can't use I. So how would we... We have... Whoops. Okay. Given array compute max in each window. I should know sliding window. I know. I don't know another way to do this other than copying left and right, which is weird. We'll go to chat for optimization, but I do need to own a solution here. Okay. So I'm thinking through this test case. We will start here and here. Then we'll increment and decrement. And then I'm trying to think how we end up over here. Okay, so maybe we just do for int I equals right plus 1 I less than original size I plus plus. Then we just check. We increment left copy okay. Sum copy equals sum minus original array of left copy plus original of right copy. Okay. So this is our update. Update. And then we check wait. Cool. Alright. sum copy is greater than sum, we do left equals left copy, right equals right copy, sum equals sum copy. And then at the very end, we need to populate the output array. So for int I equals 0, I less than window size, I plus plus, and then our output of I equals original of left how would this work? Whoa, it is bright in here. Dang. That's crazy. Anyways. Yeah, I know that's right. Alright. Let's put this in a header. If not defined, sliding window age. Define sliding window h. Should just be this. And if. Alright, let's think through this. Well, we'll start with right plus 1. And does that even make sense? Because we're not even using I. Okay. Oh. I do need to change the route. GCC. Tests. Sliding window. And then sliding window.c. Move sliding. Wait. Oh, did I make it? Hold on. Move sliding window max to questions. And then I don't think I added the right header. Alright, now we're good. In line 29. Alright, let's look at this. Oh, yep, that would do it. Cool. Let's print off off our sum again. That's weird. Might need to do -1. Sweet. Alright. So let's see what can get improved on this. Is it instruct definition? Wait. That's so funny. Okay, so we have it. I get that we didn't need the left and the right, but it's start index. Okay, I minus window size plus 1. That's right. Okay, but this is done. Fun. Test. Detect duplicates. Alright, we have an array of IDs and we're given a size. We just need to check if we have okay. We need to change this. also bring up our header. I can't believe how bright it is. That's really funny. That's funny. I don't get that. And if whoa. Alright. So it's just an array and the size. So the first thing I can think of with how to do this is for int I equals 0, I less than size minus 1, I plus plus, int val, int key equals 0, for int j equals I plus 1, j less than size, j plus plus, and do if array of j equals equals key, return true. Then return false. That's the best way I can think of doing it. In C at least, for like a base solution, this seems like the easiest. Alright. Okay. Oh, I didn't tests. That would be good. Alright, so that's our base solution, but is there a better way to do this in C? A bool array. Initialize all to 0. And that's the array. I like that. We can do that. Detect duplicate C. We'll just copy this. Comment this out. Alright, it has duplicates. The size won't change. We'll have just int max val equals 500. So we'll make a bool call it what? Scene. Mem set scene 0 max val. Oh, we just do size of scene. Okay. Okay. And then we just go through everything in the array. Okay. So if scene of array of I is true, then we return true, and we set that index to true. What do I need from memset? Implicit declaration of memset. Oh, you need string.h? Oh, interesting. Is a real hash set general solution? Initialize to 0, that's right. Yep. Oh. Bruh. Okay. Okay. We got this done. 3 more. Oh. Okay. Endian conversion. Convert 32-bit integer between little-endian and big-endian. Okay. Let's look at an image. So instead of swapping bits, it's swapping bytes. So what we'll be doing is taking, these are big, these will be our little. We'll be taking these bytes and just swapping with the actual location. So I'm thinking something really cool would be to use unions that also have a character array to swap these. So what I'm thinking is, let's first look at the test name, Endian Conversion. Okay, unsigned int. Okay. So we will have a unsigned int swap Endian 32. Right? That's the naming? Okay. What we just want to do is we take an unsigned int val. So this is where our union will come into play. Okay. First off, let's grab this. If not defined, Endian conversion 8_h. So we'll have a union uint data has a unsigned int v and a char array of size 4 of we'll call it bytes. So I'm thinking data, un data, input dot v equals val. Then we'll have this one just called result. Okay, hear me out. I'm thinking we'll do res.v equals 0. And then we'll finally we'll return res.v. But here I want to do we know it's 4 bits, or 4 bytes, that is. I equals 0, I less than 4, I plus plus. Yep. We want input dot bytes of I and we want res dot bytes of 4 minus I. Here's 3 minus I. Yeah. To equal so with my very limited knowledge, I think this could work. We already have everything, so let's just test it. Whoa. What went wrong? That would do it. I think that's pretty good. Oh, I should have done UN8. Shifted by 24. I think it's wrong. Oh, it's not wrong. Because we're shifting from here to here. then we're shifting from here to here. And then we're shifting from here to here. Nope, you're right. Oh, I'm making it freak out. Alright. Alright, I think this is where I'm gonna end for now. Because I do have some other stuff to get to. But, hopefully I'm able to record and do these last 3. But, yeah, I guess that'll be it for now. But, thanks y'all.